Okay, so this is the example that we did in class the other day. If you have a whole molecule and you want to break it up into its parts, we're going to do our example with sugar, sucrose. So sugar is made up of 12 carbons, 22 hydrogens and 11 oxygen for each molecule of sugar. So we're going to break it up into its parts. That's carbon, hydrogen and oxygen. So to start with, we're going to look at the whole molecule. So a question about it. Whenever you're given a question, you need to start labeling the information that you've been given. So the first bit here, how many grams of sugar? That's asking you, that's the question. How many grams? Grams is the weight. So they're talking about the mass. Mass and weight are the same thing. And the information that they've given you is the number of moles, how many groups you've got. So as soon as you start writing this sort of information, you can see the sort of formula that you're going to be using. So the formula has to have mass and number of moles in it. So it's this formula, the mass divided by, what's big M? The molar mass, the mass that you need for a mole. Okay, so it's a fraction. So the question is asking for the mass, so we need to find the mass. So you rearrange this equation. This is divided on this side, take it over the other side and multiply it so that your equation is rearranged. This makes sense if we know how many groups we've got, and the molar mass is the mass of one mole, one group. So once you know the mass of one group and you know how many groups you've got, you can just multiply them and work out what mass you must have. Okay, so to use this, you need to know the molar mass. So to work out the molar mass, we look on the periodic table, work out the molar mass of carbon, hydrogen and oxygen individually from the periodic table, and then just multiply it by however many you have of each of them. The molar mass is how many grams you would need for 1 mole. So that's the units for molar mass. So then you write this simple formula out properly with whatever it is you're trying to find. So you're trying to find the mass of sugar, so label this, and you need the number of moles in the molar mass, so just write in your values for this particular example and your answer, the mass. Make sure you have the units in grams. Alright, so we have 3.5 moles of sugar, and 3.5 groups of sugar weighs a bit over 1 kilogram. So when we look on our overall table here, we started with the number of moles of the whole thing. We use this equation to work out the mass. So at the moment we know 2 things about this sugar: how many groups we've got and how much does it weigh. Alright, so if we put it on the overall relationship between everything, this is the whole thing. So far we know we've got 3.5 moles and it's 1,197 grams. So we're going to break this up into its parts. So how many moles, how many groups of carbon would you have? How many groups of hydrogen? How many groups of oxygen? Once you know how many groups of each of them individually, then you can work out the mass of each of them individually. Alright, so to go from the number of moles of the whole thing to the number of moles apart, you need to relate them. So you need to know the relationship between the carbon and the whole thing, and the hydrogen and the whole thing. So if we write our equation to start with, the whole thing, break it up, we can see that one whole molecule of this, when you break it up, you get 12 carbon, 22 hydrogen and 11 oxygen. So the numbers at the front are telling you how many you have of each. So if the total mass is that, then the mass of all the parts, when you add them up, if you add up how many grams of carbon you had, hydrogen and oxygen, if you added them all up, you should end up with that. So this is kind of a self-checking activity, so you can work out if you've done it right, because you should end up with that number at the end. Alright, so obviously we're going from the number of moles of the whole thing to the number of moles of the part first. So we're doing a ratio here first. Once we've got the number of moles of carbon, then we can use that number of moles in this formula to work out the mass. So it's a two-step problem. Two step, and then you add all these together to get 1,197, which is right over where I'm talking. Alright, so number of moles of carbon. The ratio is, oh, didn't get rid of the other one. Number of moles of carbon, what you want, number of moles of carbon, please, I'm sorry about that, what happened? That's number of moles of carbon. What you've got is the number of moles of the whole thing, and the relationship between those things two is 12 to 1. So if we take the whole thing, was divided on this side, take it over the other side and multiply it. I've got rid of the 12 on 1 because 12 on 1 is the same thing as 12. So the number of moles, how many groups we've got of the whole thing, if we break it up, we're going to have 12 times that number of groups, so we'll have 42 groups altogether, 42 moles altogether. So how many grams is 42 moles of carbon? Well, we need to know how much 1 mole of carbon would be. So 1 mole of carbon would be 12 grams. We've got 42 moles of carbon, 42 groups, so we have 504 grams of carbon. So we'll just do the same thing with the others. We've got 504 grams of carbon. So we'll keep that over here to remember. Do the same thing with hydrogen. So we want to know how many moles of hydrogen. We relate it to the sugar. It's a 22 to 1. Take the sugar over the other side, multiply it. So you've got 22 times more groups of hydrogen than you have groups of sugar. So we've got 77 groups altogether. Each group weighs 1 gram, so we've got 77 grams. Same thing with oxygen. Oxygen goes with sugar, 11 to 1. So it's 11 to 1. Take it over the other side and multiply. 11, put the numbers in. 38 moles. Each mole of oxygen weighs 16 grams, so you've got 616 grams. So when we add all those up together, you'll find that the total is the same as the mass of the whole thing to begin with. Okay, yay.